WhatsApp delivers messages in milliseconds. You send a text, and the other person sees it instantly. HTTP can't do that. Here's how WebSockets work and why they changed real-time communication forever. HTTP follows a strict request-response model. The client sends a request, the server sends a response, and the connection closes. The client always initiates. The server can never push data on its own. It just waits to be asked. So what if you need live updates? Chat apps, live scores, stock tickers. With HTTP, your only option is polling. The client asks, anything new? Every few seconds. The server usually responds, nope. Over and over. Wasting bandwidth, wasting CPU cycles, and updates are never truly instant. There's always a delay equal to your polling interval. This is where WebSockets come in. A WebSocket is a persistent, bidirectional communication channel over a single TCP connection. Once established, both sides can send data at any time. The client can send to the server. The server can push to the client. No more asking. No more waiting. It stays open as long as both sides need it. Think of HTTP as sending letters. Each message needs a new envelope and a new trip to the mailbox. WebSockets are like a phone call. Once connected, both people talk freely, without hanging up and redialing for every sentence. How does a WebSocket connection start? It begins as a regular HTTP request. The client sends a special upgrade request with headers saying, I'd like to upgrade this connection to WebSocket. The server agrees and responds with HTTP 101. Switching protocols. The connection upgrades from HTTP to WebSocket. Same TCP connection, new rules. No more request response. Full duplex, always on channel. This handshake happens once. Then the connection stays open indefinitely. Now, how data flows. In HTTP, every message carries massive overhead. Headers, cookies, content type, cache control. A typical HTTP header is 200 to 800 bytes. For a chat message like, hi, that's absurd. WebSocket frames are different. The frame header is just 2 to 14 bytes. No repeated headers. No cookies on every message. Just a tiny frame wrapping your data. For apps sending hundreds of messages per second, this difference is enormous. Where do WebSockets shine in practice? Chat applications. WhatsApp, Slack, Discord. Every message needs instant delivery in both directions. Live sports scores. A goal is scored, millions see it instantly. No polling delay. Stock tickers. Prices change multiple times per second. Traders need sub-millisecond updates. Multiplayer gaming. Player positions and actions sync across players frame by frame. Collaborative editing. Google Docs. Figma. One person types. Everyone sees it immediately. But here's what people get wrong. WebSockets are not always the right choice. REST APIs? Use HTTP. It's simpler and cacheable. File downloads. HTTP has range requests and CDN support. SEO pages. HTTP. Search engines understand it. Simple CRUD? HTTP. Standard request response is perfect. WebSockets add complexity. Reconnection handling. Heartbeats for dead connections. Connection state management. Harder load balancing. Don't use them unless you genuinely need real-time bidirectional communication. What about the alternatives? Server-sent events. SSE. One-way push from server to client over HTTP. The server streams events. Great for notifications and live feeds. Simpler than WebSockets. No library needed. Long polling. Client makes a request. Server holds it until it has data. Then client requests again. A hack that simulates push. Works everywhere but clunky and high latency. HTTP/to-server push. Server proactively sends predicted resources. But it's for assets like CSS, not real-time data. Being deprecated in most browsers. Let me give you the direct comparison. Latency. HTTP. 50 to 200 milliseconds per request for connection setup. WebSockets. Sub-millisecond once connected. Overhead. HTTP. 200 to 800 bytes of headers per message. WebSockets. 2 to 14 bytes per frame. Direction. HTTP is one way, client to server. WebSockets are fully bidirectional. Connection. HTTP opens and closes per request. WebSockets maintain one persistent connection. Caching. HTTP has built-in caching with e-tags and CDNs. WebSockets have none. Every message is live. The rule is simple. Data changes rarely or client drives interactions. HTTP. Instant bidirectional updates with minimal overhead. WebSockets. Most apps use both. HTTP for pages and APIs. WebSockets for real-time features on top. WhatsApp uses WebSockets for messaging, but HTTP for profiles and media downloads. Slack uses WebSockets for live messages, but HTTP for search and file uploads. The best architecture combines both. That's WebSockets versus HTTP. One for conversations, one for requests. Know when to use each, and your applications will be faster, more efficient, and truly real-time. Follow Tech Growthspire for more. Next, how HTTP/3 and QUIC reinvent the transport layer.